Have you ever wondered how solar panels convert sunlight into electricity? It's a question that has intrigued many for years. Today, we're diving into the fascinating world of solar energy. This remarkable technology harnesses the power of the sun, the most abundant energy source on our planet, and transforms it into usable electricity. Solar energy is a form of renewable energy, meaning it's not only environmentally friendly, but it's also inexhaustible. As long as the sun keeps shining, we'll have access to solar energy. Over the next several minutes, we're going to break down the process of solar energy production into simple, understandable steps. From the science behind solar panels to the journey of sunlight as it gets converted into electricity, we'll cover it all. So, buckle up and prepare to be enlightened, quite literally. Stay with us as we unravel the magic behind solar panels, harnessing the power of the sun. So, what exactly is a solar panel? At its most basic, a solar panel is a device designed to absorb the sun's rays and turn them into usable energy. The key components of a solar panel are the solar cells, which are usually made of silicon, a semiconductor material. These cells are layered in a grid-like pattern on the surface of the panel, creating a field of potential energy. Each solar cell is designed to capture sunlight, and it's here where the magic happens. The solar cell contains both negative and positive layers, which create an electric field. When sunlight hits these layers, it excites the electrons, setting them into motion and creating an electric current. This process is known as the photovoltaic effect, a phenomenon that allows the conversion of light into electricity. And there you have it, a brief overview of a solar panel. It's a simple yet sophisticated piece of technology harnessing the power of the sun. Now that we know what a solar panel is, let's delve into how it works. Solar panels, at their core, are all about the science of atoms and particles. Now, let's dive into that science. Solar panels operate on a principle called the photovoltaic effect, a phenomenon discovered by French physicist Edmond Becquerel in the mid-19th century. The photovoltaic effect is the process by which light energy, or photons, are absorbed by certain materials, causing electrons to be knocked loose. These free electrons create an electric current, and voila! Light energy is converted into electrical energy. So, how does this play out in a solar panel? Solar panels are made up of many smaller units called solar cells, each constructed from two layers of silicon-based semiconductors. One layer is infused with phosphorus, which has an extra electron it's willing to part with. The other layer is blended with boron, which has room for one more electron. When a photon from the sun strikes the cell, it provides the energy needed to knock that extra electron from the phosphorus-infused layer. This electron is then attracted to the boron-infused layer, but it can't get there directly due to an electric field that separates the two layers. Instead, it's forced to move along a conductive wire, creating an electric current. This atomic dance happens countless times as sunlight hits the panel, generating a flow of electricity. The more sunlight, the more electrons are set in motion, and the more electricity is produced. It's a brilliant example of harnessing the power of nature in a sustainable way. But that's not the end of the story. This electricity is in the form of direct current, or DC, which is not what most of our homes and devices use. They run on alternating current, or AC. So we need an inverter to convert the solar-generated DC into usable AC. And that, in a nutshell, is the science behind solar panels. It's a marvel of modern technology, turning the sun's light into usable energy through the dance of atoms and particles. It's fascinating, isn't it? But how does this atomic dance translate into powering our homes and gadgets? How does the energy harnessed from the sun get converted into usable electricity? This is where the magic of solar technology truly shines. When sunlight hits a solar panel, it's absorbed by the panel's photovoltaic cells, also known as solar cells. These cells are made up of a semiconductor material, usually silicon, which is designed to absorb sunlight. This absorption of sunlight causes the electrons in the silicon cells to get excited and move more rapidly. As these electrons move, they create an electric field across the cell, which pushes the electrons towards the surface of the solar cell. This movement of electrons is what generates direct current, or DC electricity. But wait, we're not quite finished. You see, most of our homes and appliances use alternating current or AC electricity, not DC. So how do we make this conversion? Enter the inverter, the unsung hero of solar energy systems. The inverter takes the DC electricity from the solar panels and transforms it into AC electricity. This conversion makes the electricity compatible with our home's electrical system and the grid. It's a bit like translating a foreign language into one we can understand and use. The inverter is the translator for our solar panels, converting the language of DC electricity into the language of AC electricity. Now, this might seem like a complex process, and well, it is. But it's also incredibly efficient. In fact, modern solar panels can convert sunlight into electricity with an efficiency rate of up to 20%. And with advancements in solar technology, this rate is only expected to increase. So the sunlight that was once dangling high in the sky is now powering your blender, your TV, and even your electric car. It's a fascinating journey from sunlight to usable electricity, a journey that takes place every second of every sunny day on rooftops all around the world. Solar panels indeed do a lot of hard work, but what are the benefits of all this? Let's find out in our next segment. Harnessing the sun's power has numerous benefits. Let's explore some of these advantages that make solar energy a game changer in our quest for sustainable living. Firstly, solar energy is an inexhaustible source of power. Unlike fossil fuels such as coal, oil, and gas, which are finite and depleting, the sun is a perpetual energy provider. As long as the sun shines, we can tap into its power. This makes solar energy a renewable resource, providing us with a long-term sustainable solution to our energy needs. Moreover, solar energy is cost-effective. The initial investment might seem high, but in the long run, the returns are substantial. Once a solar panel system is installed, it practically pays for itself. The energy it produces is free, and any excess can even be sold back to the grid in many places. Plus, solar panels require minimal maintenance, further adding to the cost savings. In addition, solar energy is a silent producer of electricity. Unlike traditional energy sources, it doesn't produce noise pollution, making it an excellent choice for residential areas and workplaces. Solar energy also contributes significantly to reducing our carbon footprints. Traditional power sources rely heavily on burning fossil fuels, which release harmful greenhouse gases into the atmosphere, contributing to climate change. In contrast, solar panels produce electricity without emitting any pollutants. By choosing solar, we are choosing to protect our environment and combat climate change. Furthermore, solar energy promotes energy independence and security. By installing solar panels, homes, businesses, and even entire communities can become less reliant on the grid. This not only reduces vulnerability to power outages, but also contributes to a more stable and secure energy supply. In a world where sustainability is no longer a choice but a necessity, solar energy emerges as a viable solution. It is not just a source of power, it is a pathway to a more sustainable and environmentally friendly future. It's clear that solar energy is not only beneficial for us, but also for our planet. Solar energy, a solution that's been shining down on us all along. It's fascinating, isn't it? How the sun, an astronomical body located millions of miles away, has the potential to power our entire world. We've journeyed together through the intricacies of solar panels, understanding their structure and the science that enables them to capture sunlight and convert it into electricity. Let's take a moment to recap. We learned that solar panels are made of numerous solar cells, which are essentially sandwiches of two slices of semiconductive material, usually silicon. When sunlight hits these cells, it energizes the electrons, setting them in motion and creating an electric current. This is known as the photovoltaic effect, a phenomenon that's as intriguing as it sounds. From there, we delved into the process of converting this solar energy into usable electricity. It's a fascinating journey, one that involves inverters and power grids, ultimately resulting in the flick of a switch illuminating our homes, powering our devices, and so much more. All thanks to the ceaseless energy of the sun. But perhaps what's even more compelling is the potential of solar energy. It's renewable, it's sustainable, and it's available in abundance. It reduces our reliance on fossil fuels, curbs greenhouse emissions, and paves the way for a cleaner, greener future. It's an investment not just in our present, but in the future of our planet and generations to come. So, as we wrap up our exploration of solar energy, let's not forget the importance of renewable energy sources like solar. They are vital for a sustainable future, a future where every ray of sunlight holds the promise of energy, of power, of potential. The next time you see a solar panel, you'll know the extraordinary science and immense potential it holds. Until next time, keep exploring and stay curious.